Next diagrams. Okay, this is called the state chart diagram. Sometimes we call a state transition diagram. So this is based on the ball movement. Okay, so if you look at the diagram, okay, so this is move the ball, right? The first section, this is called the state. So ball basically is starting from one point, then after that it moves forward. For example, it's moving from left to right. Okay, from starting from left to right. So I will show you the how its ball is moving first based on the our code. Okay. Okay, I go to that code and run and show you first. Okay. So this is under my directory cdoop lab6, right? Hopefully lab6. Then I want to see, yeah, so applet viewer view.html. Okay, you look at here. Okay, if you look at here, so the basically, and then our code is here. Okay, I want to show you. Okay, if you look at here, now you look at here. So if you look at here, you see this is actually the border or frame, right? So for example, the ball is moving the state from here, this location. Now it's moved forward to the right side. And then once reached to the right side, the state has been changed and moved forward to the left side. And then similarly, this comes to bottom, bottom to top. So this the state is changing. So look at here based on the code. Now I'm going to explain to you. So the state is, for example, we're moving. Now it's right side. So if the condition is dx greater than 0, what is meant by dx greater than 0? That means the value of dx is positive. Okay. So if positive, then it's moving forward to the right directions. We call this is activity. Do move to right. We call this the activity. Okay. And here is the condition. Here is move. It will continue unless the ball world x is less than the x value is less than ball world right minus s until here, this location. This comes to this location. So it's moved forward. Okay. Now comes to the next. So that means it's moving. Once comes here, then only it reverts back. So now look at this condition here. We call the event. Moving is continue until this condition is true. That means once x greater than equal to ball world dot right minus s is comes to here, then the value needs to be changed to positive to negative. That means the value is positive. If negative, it reverts back to the opposite directions. So we call this is event. Okay, and then we call this is actions. Once this is true or false, it will go for the actions. What action here? The value need to be changed to positive to negative. Dx will be negative. And then this part is the condition we call the guard. Okay. So now based on this condition, once move from right, go to the right side, move back to the left side. Again, we have a state has been changed. So again, for these cases, move to left side. Okay, similarly, this is called activity. This is the state has been changed. Move from left to right side. So they follow the condition. Moving, this condition is here. Iterating means this looping. Move is when is true. When is moving, this condition is true. S greater than, we got the ball left. Move to the left side. Then once again move to the left side, go to the left side. This condition that is move x less than, moving. Then once reached there, again reverse back, value will be changed. Okay, so I hope you understand the concept of a state transition diagram based on the code, how you can draw. So this is for basically this part. Okay, ball left and right. You can draw one more top and bottom similarly based on this chart. So you can do these things. This is your homework. You can do it. Okay, so now move to the next. Okay, so now the next question, sometimes we give you this kind of question. For each of the 4 cases below, this is the class, all the classes here, state the most appropriate relationship between the pair of classes and connect them using corresponding UML symbol. So there are 2 questions is here. One is what is the relationship between them, and then you have to put the symbol as well. Okay, so look at the first case, car and the road. What should be the relationship between them? Okay, what should be the relationship between them? So the relationship is associations. Okay, why this association relationship? So we can explain this association using the the state line. Okay, so we can say that many car can drive in the many road. Okay, or in the many road there can be, we can see many cars. So many car can be drive in many roads. Okay, so we call association relationship. Next, look at this head and mouth. From here, you imagine this relationship is very strong relationship, right? So in that case, what we can put the relationship? Okay, so we can put the relationship is aggregation relationship. Okay, so that means if you think about the mouth and the head, we cannot imagine one after another, right? We must have in the head, we must have mouth. Similarly, if eyes and your mouth, your head must have eye, right? So relationship aggregation we can define using the diamond, okay, symbol and arrow key. This relationship we can also call the composition relationship. This is also correct. So in that case, the solid diamond, you can use the solid diamond and then arrow key. Okay. The next relationship is employee and manager. We call generalization relationship. That means the parent to child, employee. Manager is actually the child class and the employee is the parent class. Okay. So manager is one kind of employee. So we can define this generalization relationship using, you see, triangle and the arrow key. So this is the relationship. Employee is the parent class and the manager is the child class. What is the relationship? Generalization relationship, parent-child relationship. Okay. And the last one is the computer and the printer. If you look their relationship, this is also association relationship. How we can define this relationship using the symbol, the state line. That means one or many computer can link with one or many printers. Okay, so you can define this way. So relationship is the association relationship. I hope you understand the relationship between the pair of classes and how to define the relationship using the UML symbol. Okay, move to the next. Okay, now look at this. Given the list of classes, okay, draw a class diagram that shows their relationship and the multiplicities where appropriate. So what are the classes given? Vehicle, car, boat, wheel, and motorcycle. So we put the class first. Okay, the vehicle, motorcycle, car, boat, and the wheel. Now we need to think about the relationship. Okay, if you look at the vehicle, motorcycle, car, and the boat, so their relationship, we can say that what is the relationship? This one, generalization relationship. That means the vehicle is the parent class. So motorcycle is one kind of vehicle. The car is one kind of vehicle, and boat also one kind of vehicle. So we call the relationship between the boat, car, motorcycle, and these are the relationship is the generalization. Vehicle, that is the parent class, and the child class are boat, car, and the motorcycle. Okay, look at the next one. What is the relationship between the motorcycle and the wheel? Motorcycle has 2 wheels, remember, has 2 wheels. So relationship is, we call the aggregation relationship. Okay. Similarly, the car has 4 wheels. What is the relationship between car and the wheel? The aggregation relationships. Okay, I hope you understand the concept of how we can make relationship between different kinds of classes. Okay, and how we can show their relationship using the symbols and also multiplicities.